Hello and welcome to today's webinar. We're going to have a look today at how the Grenfell tragedy has impacted the way we view building regulations and how we choose materials for construction. On May the 17th, 2018, the Hackett Review was published and was received with widespread anger that it didn't recommend the banning of combustible materials as many people had wanted. At the end of an embattled day filled with constant criticism from the media, the power of public opinion turned a usually murky and impenetrable regulatory process into a political one, and history was made live on TV.
We have that exact question from Gilly Evans. Can we just hear from Gilly, please? Gilly
Why
Evans.
not ban the use of combustible cladding in high-rise buildings now?
Why not ban it now? The point Camilla was making. Dominic Raab, why not?
Well, the Hackett Review says that we need to be very careful not to focus on the false comfort zone of having a tick box approach where people say, well, one thing's banned, but actually the system as a whole still isn't safe. And what it focuses on, it's an excellent report, is the consistent focus on compliance and enforcement, which was the systemic failures, which meant the building regulations were not fit for purpose.
Could you not have said, just to interrupt you, could you not have said, I want all these things in place, it's got to be properly regulated, and by the way, no more combustible cladding?
I agree with you. There's a balance between prescriptive banning of things, but making sure we do focus, and I think her insight is right, on enforcement and compliance, because we know from civil aviation and systems that work that that's the best. But we've made it very clear that we will proceed to ban combustible cladding.
Until that day, there'd actually been no mention that there would be a combustible materials ban. Many had felt after the ban was announced that the war had been won despite many battles having been lost on the way. However, the process of implementing the ban has been fraught with frustration, as the government has failed to implement the widespread ban that the vast majority of the public and the industry had wanted from happening. The whole process of building regulations, how they're arrived at, written, and what they intend to serve has been called into question because of Grenfell. The current approach is very vulnerable to the influence of large corporations in their desire to maximise profits and sell their products, and doesn't always work in the interests of the public that it intends to serve. Building regulations are also evidently not a quality standard that clients should believe will assure them of a building they can be proud of, nor should it be used by building professionals and engineers as a guide to the choice of an appropriate material during the construction of a building. What we're going to look at is how the construction process has been affected by the developments following the Grenfell Tower. And rather than look just at the combustibility of materials and fire regulations, we're going to look at other issues relating to construction materials that the regulation changes might actually impact. 20 years ago, there was a fire in a block of flats in Irvine in Scotland. The MP at the time, Brian Donohoe, recognised that this fire could have been much worse. Sadly, one person died, but had the fire happened during the night when everybody had been asleep, the death toll could have been much higher. So a committee was formed to look at the cladding that was on this building and the external fire spread, and it made a number of recommendations that sadly were an indication of the failures that were to follow over the next 20 years. The words that seemed to strike the most from what was said at the time was that it shouldn't take a serious fire in which many people are killed before all reasonable steps are taken towards minimising the risks. It's clear to understand that building regulations themselves are actually very simple. All they dictate really is that you shouldn't have a building where the external spread of fire isn't sufficiently restricted. However, doing so is quite a difficult process. So we have a suite of approved documents approved by the Ministry, which gives detailed guidance on how to actually achieve the restriction of external spread of fire. The particularly contentious clause in approved document B, which relates to fire safety, is clause 12.7, and this has been argued about much since the Grenfell tragedy. Just to recap on some of the terminology relating to cladding, the cladding system comprises several key elements. We have a mounting system which is usually made of aluminium brackets and extrusions on which the cladding rests. We have the insulation which sits in the cavity. The cavity provides ventilation to prevent moisture from damaging the building. And then we have the cladding, the external surface itself, sitting on the front of the mounting system. This can be a wide variety of materials, from steel, composite materials, solid aluminium, brick slips, and so on. This is a face-fixed system. It has a flat sheet with exposed rivets and connections and achieves this kind of finish. But most modern buildings and architects choose to use a cassette system, which achieves a wider variety of aesthetic finishes and is largely what we see today. There's no question that these are undoubtedly top-of-the-range expensive systems. This is not a cheap way to refurbish or design a building. After the Grenfell tragedy, Dr. Barbara Lane from Arup was appointed as the fire engineer to the inquiry. One of the key questions that she was looking to answer was the cladding itself, not the insulation, but the cladding in line with the guidance provided by the central government. Her report has already highlighted a vast number of failings in the whole process that led to the refurbishment, including building control, the product certifiers, the testing process that leads to the certification, and so on. Soon after the disaster, it was clear that the certification for many of the products wasn't adequate and some were removed from the market. But the whole process isn't just limited to the cladding itself. The disaster exposed a wide range of issues with the construction industry and how it's regulated and controlled. The design itself was severely flawed, but there are also many other parties who have received a lot of attention and criticism. Every single one of these organisations that were involved in the refurbishment all have questions to answer in the role that they played. Going back to one of the key items of whether the cladding was compliant or not, it's Barbara Lane's opinion that Class O ACM as used on Grenfell could have been compliant with approved document B, section 12. And that is absolutely critical to understanding what went wrong in the Grenfell Tower and how the regulation process could be changed to suit moving forward. In contrast, the Hackett Review took approximately 9 months to come up with 100 pages compared to Barbara Lane's document of well over 1,000 of mainly prose. When the Hackett Review was announced, we were led to believe this was going to be an independent review of building regulations and fire safety. But when you read the terms of reference that she was given by her employers at IMechE, it was quite clear that she was going to do nothing of the case. She was asked to look basically at the system surrounding building regulations. And it was quite apparent when her review report was released that she'd started from the premise that actually the cladding on Grenfell Tower was already banned by the guidance and the regulations. The regulations clearly shouldn't have never allowed a material like that on the building, but she assumed that the guidance in approved document B actually insisted that the cladding should have been limited combustibility. She had a very hard time on the day that the report was released, mainly because she ignored the elephant in the room, which is that you should simply ban the types of materials that were there. If we move forward to 2015-2016, we can see that we have about 8 buildings now. So approximately 1% of buildings were now had limited combustibility ACM cladding. So it was very clear that the industry, all the professionals, the building control, fire engineers, specifiers, architects and designers all understood approved document B to mean that you needed Class O or Class B cladding on a building of over 18 metres. Among the highlights of the Hackett Review were some good proposals. The regulatory framework should require industry and regulators to agree solutions so far as is reasonably practicable. Now, the part of that clause which worries me is industry and regulators to agree solutions, and we'll come back to that. She also said that using products which are non-combustible is undoubtedly the lower risk option. However, what she failed to do was combine 6.12 and 7.10 to come to the conclusion that actually one of her recommendations would be to remove combustible materials. She also made the valid point that actually if you're specifying combustible materials on the basis of their tested performance, the obligations on the building owner or duty holder is quite onerous, and that you have to maintain the building to the standard of the test that it went through for its entire life. So Dame Judith now travels the world talking about her review, and she underlines literally the fact that she was only asked to review the system itself. Who was going to look at the regulations? We just don't know. So many of the problems in terms of implementing a combustible ban, there have been a number of reasons put forward. As you've heard Dominic Rabb say, we don't want just a tick box exercise which gives the false impression that we've solved this problem just by banning combustible materials. but there have been many arguments that have led to procrastination in getting an effective combustible ban implemented. I use this analogy a number of times from different perspectives. It's quite clear that, to me, 67% mortality rate in pigs is caused by inadequate construction methods. However, there are people that look at this image and think that actually the problem isn't with the pigs and how they build their buildings. It's down to more deep-rooted social problems within the wolf community, and that actually the solution here is not to educate the pigs on how to build things, it's to actually have culture change within the wolf community. One of the messages we repeatedly hear is that we should leave it to building science to determine what materials are used in construction. However, the people at the top of the fire engineering field quite readily point out that actually it's very difficult to predict how a building is going to burn given the material properties within a system. The analogy I use is that predicting how a system is going to perform based on the material properties is like predicting what a musical instrument is going to sound like based on the materials that you've constructed it out of. Another argument that we hear a lot is that we should sit back and look at industries that do actually get it right. I can use the same image, however, in terms of innovation, to show that the automotive industry is also subject to corruption, and the diesel emission scandal is evidence of that. The aerospace industry also has its own problems, and more information that emerges about the Boeing 737 MAX 8 problems, the more you see regulatory problems there as well. Even NASA, in putting satellites into space, has problems with product certification and testing. The common theme throughout this, to me, is a lack of independent regulatory control that is totally immune from the pressures of commercial organizations. And the final one is that everything we do, it needs culture change and an improvement in competency. Well, those are vacuous words that you could pretty much apply to any problem around the planet today. What we've also learned is that building regulations, and fire regulations in particular, only look to protect life. They do not look to protect assets. But we've had some significant fires. We've lost the Glasgow School of Arts. We've lost a big part of Notre Dame. Many people lost their lives, possessions in a self-storage fire in Croydon on New Year's Eve. We've had a spectacular fire at a building that won awards for its fire safety, at the Ocado Fulfillment Centre, which caused massive disruption to businesses and local houses were evacuated and so on. So we have to question whether fire regulation should go far beyond actually just being able to get out of a building alive. Toxicity is an issue that is very contentious. Before Grenfell, there was a report commissioned by the EU that the BRE carried out, looking at whether we should regulate the toxicity of building materials. However, the report itself highlights some of the inadequacies in our regulatory process and the lack of leadership that we have. Basically, the report showed that the responses didn't agree that toxicity should be regulated. That's not surprising given that many of the responses came from plastics manufacturers and their lobbying organisations. One of the quotes from the report gave a reason to not introduce toxicity regulation in that it could actually remove some products from the market. However, the report did actually state that in areas where toxic smoke could lead to compromising of escape routes, this should be looked at. And it's possible to argue that actually building regulations do regulate toxicity if you interpret the means of escape requirements slightly differently. Means of escape requirements being clear and usable at all times usually is interpreted as being clear from physical obstacles. But as you see from the next video, which was taken from the night of Grenfell Tower, smoke itself could be construed as being a prevention of using an escape route. When that door is opened, in front of the person who opened the door is a white wall 1 meter away. However, all you can see is total blackness. Fortunately, that family escaped the tower that night, but sadly, the unborn baby was the 71st victim of the fire. So we do have increasing evidence, and there is a lot of history that shows that governments, in the face of credible evidence, do change regulations. However, this can take a long time to manifest itself. There is more evidence emerging, particularly from firefighters, that toxicity can have very damaging effects on your long-term health. Some of this data is accumulated over many, many years. What we've seen, though, is the nature of toxicity seems to be changing. If you look at this graph, up until the 1960s and 1970s, the number of people that died from the effects of fire was largely due to burns. But during the 70s and 80s, the proportion of people that died actually from the effects of gas and smoke rises considerably and plateaus into the late 90s. So the nature of the materials, presumably, that people are dying from the burning of has changed over the last 50, 60 years. And cladding systems represent a problem in themselves. Combustible materials burn differently, whether they're in ventilated or unventilated conditions. On the left-hand column, the flame retardants that are added are unbonded, so it doesn't really matter how the material burns. You can see from the chemical symbols that these gases, when combined with moisture, form acids, which is why we often hear of people reporting irritants in their eyes when hydrogen chloride mixes with the water on your lungs and in your eyes, it's going to sting. In the right-hand column, with a poorly ventilated fire, as you would find in a rain screen situation, incomplete combustion leads to complex molecules which have potentially damaging long-term health effects. Carbon monoxide and hydrogen cyanide are easily got rid of by the body. However, they are incapacitating in the early stages of fire. However, if you've survived the fire, your problems might not be over if you've been exposed to a significant level of smoke inhalation. More and more evidence is showing us that long-term health problems can affect the people who've survived fires such as the Grenfell Tower, and this evidence is likely to increase over time. Other evidence as well suggests that actually external fire spread in itself might not be the only issue that we need to be concerned about. A recent project run by the University of Central Lancashire and the Fire Protection Association analysed the toxicity of modern cladding systems. The vent that you can see at the top of the rig was almost an afterthought and it was almost discarded, but it turned out to be one of the most significant aspects of the tests that we did. A number of combinations of materials, non-combustible cladding, combustible and non-combustible insulation, were analysed, and part of the test included analysing the gases that went into the vent even before the fire actually reached the vent itself. Interpreting these results and extrapolating them as if these gases had filled a 50-metre room, such as a kitchen or bathroom that the people in the flat above were protecting themselves in, shows that even with non-combustible cladding, the combustible insulation systems had lethal doses within half an hour, even regardless of the fire having spread to the flat above. This calls into question two key things. One is the stay put policy, and the other is whether toxicity should also be added to the BS 8414 test, which looks at the fire safety performance of systems based solely on their external fire spread. Looking further afield than just fire protection, the combustible ban might have implications that weren't necessarily intended, hopefully beneficial. We're bombarded today with information about plastic pollution, bottles floating in the ocean, and microplastics being found everywhere. It's not just pollution that we see that is necessarily the problem. Much of the combustible material being stripped off buildings that are considered dangerous today in the building safety program will be headed to landfill. There are no viable recycling schemes for thermoset plastics at the moment, and much of this material is useless in any other form. We're also seeing that around the Grenfell fire, many of the flats, the curtains, the carpets and so on are contaminated with the byproducts of the fire. The polyurethane foam market in 2018 was estimated at $50 billion, so these are very large numbers and it is growing at a considerable rate. The video you're about to see shows nothing to do with the combustibility of these products. Here we have 100 millimeters of phenolic foam insulation, and all we're going to do is cut it. So, as you can see, it leaves quite a rough finish to the product, and all this is basically going to come off at some point. Quite smelly too. If you zoom in, what you've got from just 1 metre is this, and you can see the dust flying around. You've got basically a powdery mix of polyurethane based thermoset plastic with some kind of flame retardant mixed in with it. Now obviously on a building site, what's going to happen to that is that it's just going to fly away out into the air, into the water streams, into your fish, into your stomachs, into your areas of natural beauty, and so on. There you go. A rough estimation is that 3 road tankers full of microplastic from cutting of thermoset insulation are being dumped into our environment every single day. A material that was heralded as part of the solution to the global carbon dioxide problem may actually be creating other problems itself. Very similar to the diesel situation that we have, where the particulate emissions seem to have outweighed the benefits from carbon dioxide production. So, do we wait for evidence to develop, or should we start acting now? History has many lessons for us in this respect. Asbestos. Asbestos controls were first introduced in the UK for processing in the 1930s, with breathing apparatus recommended. However, it was 75 years before asbestos was banned in the EU, and it remains widely used around the world and is in fact growing very rapidly, including in America. Even between 2001 and 2012, nearly 8 million metric tons of asbestos was used in Europe alone. So that gives you an idea of the amount of asbestos that was used in that 75 years between the first controls on asbestos and actually being banned in Europe. Asbestos is also an interesting material in terms of being wary of new materials that might emerge as a result of the combustible ban. A naturally occurring mineral, it has microfiber structure which presents enormous long-term health problems, but it is also an indication of what could go wrong with other materials as well. So here are a few examples of what things that we should be careful of. Materials that are entangled together present unexpected problems with recycling. I'm not just talking about composite materials, but even aluminium window frames, which have EPDM seals and so on, are very difficult to recycle, and many recycling centres will reject them. Products that have complex chemistries as well leave huge questions in terms of their long-term end-of-life recyclability, and also the scale of the structures within materials and whether they will present a problem. To understand this a little better, we're going to show a video of an immune cell trying to attack an asbestos body entering through the lungs.
After the asbestos fibers lodge in human tissue, the immune system sends a special cell known as a macrophage that attempts to wrap around and remove the fiber. But unfortunately, not all macrophages are successful in removing the fibers, which causes the fibers to build up over time. The chemical reactions that occur during this process result in compounds like reactive oxygen species, which damage DNA and lead to scar tissue or fluid buildup.
Other materials perhaps that we might want to be wary of that are unproven at the moment, anything to do with graphene, in my view, is a potential danger and has the same sort of scale that a macrophage would have difficulty in dealing with. This image shows graphene platelets, so they lack the large networked structure that the human body tends to find easier to get rid of. Platelets themselves are a similar size to an asbestos fiber. You don't have to look very far on the internet to find a number of papers highlighting the potential concerns of graphene. Also aerogels. I'm very optimistic about aerogels being a great material for the future. However, they also possess a structure with similar dimensions, those which could potentially cause a problem for the human body. So, in conclusion, the message I have to the engineering profession is to take up the challenge of specifying materials in a responsible way and not leave it to legislation. Fundamentally, we should all stick to what we understand. It's a great message in life in general. Warren Buffett used it as his fundamental principle for investment, and I also think it applies to construction materials. The industry has got an awful lot of work to do to prove that materials are safe, rather than use them until we have proved that they're actually unsafe. We would encourage clients to understand the limitations of what regulations are intended to achieve and understand what they are trying to achieve with their buildings and go beyond what the statutory guidance requires. Everybody should play a part in driving change in regulatory control. Regulations are absolutely imperative for ensuring that the entire industry sticks to the best practice and people don't cut corners. Read the certificates. This is an important message which has become all too apparent in the last couple of years. The actual scope and application of materials, it's very crucial to read the limitations in the certificates and, if necessary, interrogate the test certificates and classifications of the materials as well. Also, spread the message, lead by example. In this internet age and social media and so on, it's possible that the public can actually drive regulatory change to end up with regulations which serve them and not the needs of large corporations. And if you're particularly passionate about this subject, we are establishing a construction materials group within the IMechE and the Construction and Building Services division. Anybody that wishes to be part of that can contact me on the email address provided, and hopefully together we can help change the construction industry.
Many thanks for the presentation, Jonathan. You should see the option at the bottom of your screens where you can submit your questions. I will pass back to Jonathan now, who will be able to take your questions.
Okay, thanks, Emma. I'd just like to say, firstly, if there is anybody who found any of the content upsetting or distressing, I do apologise. I try to make a point of not putting pictures of burning buildings and so on into my presentations, but obviously there are some things that need to go in to make the points, but sorry if anybody found any of that troubling. While we wait for any questions to come in, hopefully what was only a 25-minute presentation, the message that I'm trying to get across is that the issues that we've learned from Grenfell and the past 20 years or so are not just limited to combustibility. The same problems and restrictions that we have with our regulatory system and how we come up with regulations also affect broader issues, as I've mentioned, such as health and the environment. And what I'm looking for is support within the industry to try and drive change, which is not going to come through any of the recommendations called by Hackett. Dame Judith Hackett, for example, didn't look at all at how regulations themselves are arrived at, who actually contributes to that process, what are their objectives and motivations and so on. So it's up to us as an industry, I think, to try and drive that change and not wait for regulatory processes to grind their gears over the many years. We do have a couple of questions which I will try to address. Thanks for a very interesting presentation. Thank you, Chris. Could you please comment on how the role of the market surveillance and building control might change going forward? Which is a really good question, somewhat rhetorical, I suspect. Building control and the regulatory system are very intimately entwined. We've obviously had the privatization of building control in the 80s under the Thatcher government, and now we have a combination of local authority building control and approved inspectors under private companies, and there's been a lot of criticism of the structure of that. And again, that was really overlooked by Dame Judith Hackett, who now is looking to give building control even more authority over buildings over 30 meters going forward. I think it's a real mistake not to look at the competitive situation within building control and the fact that companies can actually provide engineering consulting services as well as, in perhaps a separate division, they can also sign off buildings as well. So there's no natural tension between those two disciplines which would normally exist. So I think that we desperately need to look at building control and how we create an environment where it's in the building control industry's interest to actually find faults with buildings rather than make life easy for their clients and attract business and for commercial reasons. Is there anything we can learn from US and Canadian standards and regulations? Thanks, Ian. Yes, I think there's an awful lot we can learn. I think both positively and negatively, I think what we've seen in the US is that the standards there are very vulnerable to lobbying from organizations. Some people argue that, well, we don't have the similar problems in the US and Canada. We have different building methods in all areas of North American continent. So it's hard to draw direct parallels, but for instance, there was a move to ban polyethylene ACM cladding from buildings some years ago in the US, and then when sprinklers were introduced as being mandatory, the manufacturers of these products managed to change the legislation again to allow polyethylene ACM in buildings which had sprinklers on. So it's a bit of a game of cat and mouse, and I think what we can learn across the world about regulatory systems is that unless there is some real leadership within non-elected civil services, if you like, then really it's just left to be a battle between manufacturers and people with commercial interest, and there's nobody really to stamp their authority on the situation and say, look, this is what is in the public's interest and this is what we're going to do. So yes, there is a lesson that we can learn in terms of combustibility and so on, but I think the main lesson we see around the world, both geographically and across all the different industries, is that when you fail to have a truly independent regulatory body that acts in the interests of the nation, then things tend to go wrong. And that was why I used the analogy of the Clean Air Act that was introduced in the 70s in America, where Congress basically said to the automotive industry, you've got 5 years to reduce emissions by 90%. And that was at a time when the technology simply didn't even exist then, and the automotive industry, Ford, Chrysler, General Motors, and so on, said there's going to be millions of people made redundant and so on. We're all going to be riding bicycles around. But Congress, driven by great public opinion from California, stuck to its guns, and 5 years later, and billions of dollars of research was spent, and basically from nowhere, the catalytic converter was invented, and that changed automotive technology moving forward. And that wouldn't have really happened had it not been driven by the public and what the electorate wanted in California. And I see a similar parallel with building regulations now, and the video we showed at the beginning with Dominic Raab capitulating in the face of public opinion is that Grenfell was an event of such magnitude that the pace of change really is being driven by the public and with some support from the media and some politicians and so on. And that's transcended for a rare opportunity for that to transcend the normal regulatory process where things tend to go on behind closed doors and with various committees and so on. Well, at the moment we're seeing on combustibility, we're seeing it played out live on television. I've got a couple of questions on how is it possible to control new materials, which is a very good one. It's been the position of the government pretty much since the Grenfell Tower that it's not their responsibility to try and keep track of new materials and so on. But the point I was trying to make with the examples in the presentation was that there are lessons that can be learned from history and materials that have gone badly wrong, such as asbestos. And there are characteristics of materials that we should be wary of and we can actually look out for. For example, but having said that, we do need to learn the lessons. So we need some kind of organization or body, which is why I'm trying to drive this through the Institution of Mechanical Engineers, which is probably the most impartial body I think that we can use to be a voice for having responsible material selection in the future, because we're not really representing one single discipline or one product set and so on. And I think that our organization can really have a great influence on regulatory policy moving forward, bringing in lots of people with passion from different disciplines and so on to try and flag up some of the issues going forward. For instance, in the 90s, when you look at the Garnock report, there were many examples of people saying that the testing regimes just weren't suitable for composite materials, non-homogeneous materials, and so on, which is why we have this argument at the moment that with Grenfell, was the ACM material, the composite material used there, actually compliant with the building regulations, or if you like, the guidance. So we're looking now, for instance, to try and change the testing regimes, the small-scale testings for composite materials, because ACM is a particularly unfortunate material when it has a combustible core, because it has a very thin layer of aluminium, which on a small-scale test protects the combustible core. However, in a large-scale test with a real fire load, that aluminium will melt, and you've got a sheet of highly combustible material with a very large surface area to volume ratio, which is obviously going to burn very, very quickly. So the whole process has been called into question, not just about the regulations, but also about the testing and certification industry that we have to support that, and also the building control. So those three key areas are areas where I think that professional engineering can make a big difference. It appears that the system used at Grenfell caused the windows to fall out, thereby destroying the integrity of the adjacent apartments and making the stay put advice useless. Ian, thanks again. Well, windows have virtually no fire resistance whatsoever, and I think it's wise to continue to treat them accordingly. Pretty much everything that could have gone wrong at Grenfell did go wrong. I think even if the glazing hadn't fallen out, I think we would have had a similar situation. The filler material used around the windows clearly was combustible, so there was, and the membrane that linked the interior of the flat to the exterior was a very easy path for the fire to spread. And also, the stay put policy relies on compartmentation to be successful, and that's in practice what we're seeing with fires. Quite a difficult thing to achieve. It not only requires the appropriate specification of materials, but they've also got to be assembled extremely well for this to work, particularly when you're looking at compartmentation of smoke. And smoke is becoming, if you like, in the spotlight more and more now, because the research that I showed you from the Fire Protection Association has shown that even if you can actually limit the external spread of fire in a block of flats, the smoke, as it travels up into the flats above the fire of origin, potentially can still be lethal. So, and that points again to the certification and testing regime that we're looking at. There's currently a review of the BS 8414 test, which only measures really external fire spread and the rate of spread of that flame. However, even if you manage to produce a material which was combustible but didn't spread external flame, if it produced large quantities of toxic gas and smoke, then it still has the capacity to be much more dangerous than an equivalent material which didn't produce that. So we really have to revisit the issue of smoke and toxicity, and I'm sure that the public inquiry over the next year or two will do that. But as I say, the message I'm trying to get across today is that these issues, frankly, are rather obvious, and we shouldn't wait to make common sense decisions. Ollie Potter just posted a question. What are my thoughts on the impending IMechE test on HPL cladding with stone wool insulation, considering the problems of the BS 8414 test? That's a very topical question, and I should say that I am involved in this test program. I don't think that is a combination which is frankly a huge amount of interest. They're not going to use the BS 8414 test as part of the screening program for the non-ACM materials, but an 8414 test is pretty essential to truly understand how the HPL cladding will behave with the insulation. It's going to be an absolutely crucial test. I think if the HPL performs badly, then it's a very damning statement again on the regulations in Approved Document B, because within Approved Document B, it is possible to use Class B high-pressure laminate cladding with mineral wool on buildings over 18 meters. or it was, should I say, before the new regulations came out in December. But it is still possible, obviously, on offices and hotels going forward. Having said that, when we did the DCLG tests back in the summer of 2017, it was seen that the polyethylene ACM actually failed quicker than it did with the combustible insulation. So I suspect with these materials that have quite a lot of energy in them, then that the insulation isn't going to make a huge difference. The overwhelming obvious point is that, well, we just don't know, and it's unacceptable. I wrote to IMechE in July of 2017 and said that they should do these tests urgently. So I'm obviously very unhappy that it's taken 2 years, and it's only by luck that we've not had a serious fire in the meantime. The big question as well about HPL is that it's the grade of HPL which is being tested is my biggest concern, and I'm not privy to that information at the moment, but I'm strongly suggesting or proposing that the grades that are tested must be the standard grade high pressure laminate cladding if they're planning to do the fire retardant, flame retardant grade as well, because I believe that we've got enough evidence to suggest that the standard grade material has been provided in a lot of cases, probably where the client or even the contractor thought that the fire retardant grade was actually being supplied. And we really need to understand the difference between those two grades of material. And it's quite possible if you look at the very limited test data that we have at the moment, because you could say, well, why would you test it at the moment? Because it's not compliant anyway. But on the basis of the very limited information that we have available at the moment, it is quite possible that the standard grade of high-pressure laminate cladding, regardless of the insulation, could be as dangerous as the polyethylene ACM that we saw on Grenfell. And in some respects, again, coming back to the issue of toxicity and smoke, because there is up to 2/3 the amount of combustible material within a high-pressure laminate sheet, even if the rate of spread of the flame isn't as great as the polyethylene ACM, it could actually produce more smoke and gases, and in another respect be more dangerous. Catherine, will a recording of the question and answer be available? The sound has failed. Well, I hope the sound hasn't failed for everybody, but I'm sure if you get in touch, then we'll be able to provide the information should you require it. In the hope that the sound hasn't totally failed, I shall continue. Chris sent a question. I would suggest that there are also questions to be asked about the adequacy of design and materials of consumer devices, in particular failure modes and rates. Yeah, I think that the whole philosophy, obviously that's, thanks Chris, sound's still working. Sorry Catherine, I don't know what's happened to yours. I agree. The same philosophy about regulations and the role of the regulatory bodies. If you look at the IMechE website, for instance, I know they don't look after consumer devices, but their mission statement basically is to look after, make great places for people to live and work, and I think that that's contrary to a lot of the philosophy and principles under which they produced their regulations over the last, well, as far back as we can actually tell. A lot of it seems to be driven, as you can imagine, politically, with politicians not really wanting to burden industry. Some of the comments about Lacanau during the coroner's inquest, where it was stated that actually if you make it materials less combustible, there's less choice, which could be interpreted as meaning actually that's going to make buildings more expensive to build. But at the moment, we're sitting looking at a future which is going to behold us to compulsory testing, certification, increasingly stringent building control inspections, and so on. We've just created an industry which is going to be extremely expensive and bureaucratic moving forward. So that has backfired somewhat. Okay, I've got another question about how is it possible to control new materials through regulations. I think that's an extremely difficult one that really is where we need to start from in terms of if you think of an analogous situation. I'm suggesting that it's quite possible for us to come up with a material with unknown future problems, but I'm also suggesting that it might be possible to spot the characteristics of those in much the same way that we have clinical trials for drugs to make sure that something on a small trial looks very promising. When we release it to the wider population, doesn't become a major problem. I think we need something similar to review the classification of new materials, particularly when they're complicated or novel in terms of the dangers that they may pose to the public moving forward. On the other hand, I think that what we're seeing now broadly is a new wave of new materials driven by the regulations, hence my point about people saying that they thought that increased regulatory control would thwart innovation. And again, I've maintained this argument right from the outset that I think new regulations drive innovation, and I think innovative companies will respond to the market opportunities given to them and come up with new products. And we are already seeing that now. We've had a flurry of new products come into the insulation market. We're seeing sheathing boards now that are more non-combustible than ever, and the market is about to see an ACM product as well, which has an A1 classification. So, ironically, that might possibly be the safest material to actually clad a building on in terms of its traceability, supply chain management, and so on. And we're also seeing a huge change in architectural design as well, and a big resurgence of natural materials like clay and stone. Bricks themselves are in extreme shortages at the moment. Architects, after a year or two after Grenfell, are now designing buildings where it's not good enough for a material to be non-combustible. It actually has to look non-combustible as well. So what we're seeing in the cladding industry is a bit of a departure away, which I'm very grateful for, from the silver rectilinear panels that you see on many buildings, many hotels, and so on. If you're obviously managing a hotel or a commercial building, you don't want your guests and visitors asking at reception what the cladding's made out of. So a statement from architects in that brick slips, brick systems, and stone and materials which obviously aren't ACM are being used much more prevalently moving forward. Hi, Stuart. Should the UK regulators look towards the property loss prevention testing regimes developed by FM Global to shape the principles of UK statutory regulations? Absolutely. I think they need to go further than that. My message is quite brutal and somewhat dismaying that if you ask people within the regulatory bodies about fire safety, undoubtedly the only objective for regulations have been to actually get people out alive of the building. You could use the somewhat cynical analogy: if the building itself collapses in a burning, smoking heap of debris behind you as you run out of the building screaming with your hair on fire, that's still seen as a regulatory success, and that attitude has to stop. And as you can see from my presentation, that it's probably not the end of your problems actually getting out of a burning building if you've been subjected to a high degree of smoke inhalation as well. So you might have health problems that might persist for weeks, months, or even years. So we need to change that attitude entirely. So coming back to my point about how the government and IMechE needs to look after the interests of people, not just occupants, but also people living in the surrounding areas, and anybody really who's affected by the environment, which is everybody. We need to look at regulations that reflect that. So we need to look at, as you say, we need to look at property prevention, which was the analogy that I used with the Shoreguard building fire that we had in Croydon on New Year's Eve, with hundreds of people losing their entire life's possessions, irreplaceable objects, sentimental objects, and so on, people who are moving from house to house and so on. So it's not just property possessions, but we also need to look after long-term health and the environment. So I think that what I'm trying to do within the Institution of Mechanical Engineers is set up a construction materials group which will state out these policies, and working alongside other initiatives, for instance, within the institution which are looking at, for instance, single-use plastics and plastic packaging within the construction industry. I know that this isn't all about plastic. As I've used the other examples of graphene, aerogels, and so on, we need to have a holistic view of construction materials and what we need to try to do with them moving forward, and look at the various roles of building control, the regulatory bodies, skills and competency, and so on, but come up with a package of measures that will help us, if you like, avoid the Wall-E type of dystopian vision of the future. But as I've said as well, I've tried to raise awareness in my short presentation that it's potentially not just the plastics or the waste or the rubbish or the contaminants that you can see that are the problem. It's the micro nanoparticles and so on that we can't see, because in my mind those are by definition possibly the more difficult ones to ever clean up. Well, I think that broadly comes to the end of the questions that have appeared in front of me. So if there are no other questions at the moment, then I'll hand back to Emma, perhaps, and say thank you for listening. And as I say, if you are passionate about this subject and want to get in touch with me, I'm looking for engineers and scientists within the Engineering Council organisation to join me and help put together a group and a team that can be a voice for driving change within construction materials. Thank you.